okay, is between the applied force to the element. Okay, so I'm going to copy this diagram. I'm going to paste down here. I'm going to like squash it, and you can see the difference, right? So over here, if you look at the forces now, right, they are perpendicular to the what? Neutral axis. That is why you use this distance over here. And the distance is up to the what? To the element. Okay, so again, if the applied force is perpendicular to the neutral axis, the perpendicular distance is between the applied force to the what? Element. You can see the difference now. One is to the neutral axis, right? The other one is to the element. Because if you get this wrong, your stress is wrong, and we are wasting we are wasting time again. Okay. I thought someone had a question. No, no one have a question. Okay. So for our last view, the last view, I explained quite substantially regarding what's a moment, what's a thought. It's going to be quick. Okay. So this is the this part that I'm writing now. This is the critical part. As I said, a lot of students make a lot of mistakes. Not just students, even engineers. Okay, make a lot of mistakes on when is it towards the neutral axis and when is it towards the element. Okay. And then the last view, that we're going to do, okay, we are going to view it from the front. Okay, so if I'm going to draw my direction, this is the Y, and this is the Z. So we're viewing from the front. I'm going to draw it wider a bit. Okay, right. So this is our hidden feature. Okay, and I'm going to draw our element. This represents our element H. Then we have one down here. This is our element K. Right. So one is our element H. The other one is our element K. Then we have our forces. This is at 150. And then we have a 50-pound load. And then we have a 200-pound load. Okay. And then we have 150 coming towards us. Okay. So now again, I'm going to draw our neutral axis. Now our neutral axis is a dot. Okay. So this is our neutral axis. Okay. So anything else? So okay. So now let's say, remember I told you, let's analyze the real arrows, not the cross and the dots. Okay. So when you do over here, okay, you will say that going towards the left is positive. Summation forces in the VZ direction. So this is equal to 150 plus by 50 minus 200. So this is 0, right? We've done this before. Okay, we've done this on this analysis over here. We've done it before. But if you are not sure, okay, you see, you do it, and then you realize that both you are calculating are for your VZ. You realize you've done it before. It's okay. Now the thing is the 200, right? The 200 now has a perpendicular distance. All right? And this perpendicular distance is again 10 inch. Now, is it a moment or a torque? So I'm going to draw the deformation pattern. Okay, I'm going to draw the deformation pattern. So the deformation pattern will looks like this. The 200 will cause a deformation that look like this. Right? Now I want you to look at the neutral axis. Is the neutral axis a smiling face or a sad face? It's neither. It's still at the same position, right? So just to quickly recap, right? Just to quickly recap, look at this. The neutral axis remain in the same position. So what is this? Bending moment or torque? It is a what? A torque. So now we know, right? So torque in the x direction. So if I were to redraw my transformation, I do apologize my silliness again. So this is y and z. This is rotation about x, right? So from here, we know that the torque in the x direction is equal to 200 multiplied by what? 10. So this is equal to 2,000 pound-inch. Okay? And that is your torque. Okay, so in your torque distribution, right? Remember, when we talk about torque, we have our distribution. Right? So this is our shear stress. This is our radius, right? We know that at the radius that's maximum is going to be your tau what max. Okay, so now what do you write down? Okay, so you write down that element H will be equal to element K, and it will be equal to your tau max. Why? Because your tau max is equal to TR over J, right? So the radius, the R radius for element H and element K are the same. Okay, so only if you get this right, okay, then you can now construct your what element. If you get this wrong, okay, yeah, that is why this topic is so critical. Okay, this topic is so critical in this context. Okay, as in if you get it wrong, your answer it's a snowball effect. Okay, you're wasting your time. Okay, so from there, I'm going to stop the class now. Okay, I'm going to post the notes and the video hopefully after I come back, if there's nothing wrong with me. If not, you'll see the videos and the notes tomorrow morning. Okay, so I will see you guys next week then. Thank you. Now I will, those of you that have to redo your